Hello again, this is Mr. Smith, and this is 1.20 Features of a Parabola. So now we know how to draw a parabola and some basic characteristics. We want to go a little bit more in depth with the features of a parabola, so specifically the graph of a quadratic relation. So some features of a quadratic relation, well, we know the formula from yesterday was, or from last lesson, was y equals ax squared plus bx plus c. The graph of that is called a parabola. The direction of opening is either up or down, and that actually just depends on the a value, if it's positive or negative. The maximum or minimum point is known as the vertex. This will either be a maximum if it's opening down or a minimum if it's opening up. So it does depend on the opening if it'll be a maximum or minimum. Your x-intercepts. So this is a little bit newer, new concept. Our x-intercepts, which you guys should know what an x-intercept is from equations of lines. But whenever we're dealing with parabolas, we call them our zeros. And we're going to see a little bit more why in some later lessons, in about 2.2, 2.3, somewhere around there. So the y-intercept is the c value in standard form. So if x equals 0 in our standard form up here, I'll just write that out there. If x was 0 in that equation that I indicated with the arrow, then the c value would be the only thing that would remain. Therefore, it's the y-intercept. Points follow a step pattern, which is always a multiple of 1, 3, 5, 7, so on and so forth. They increase by 2. So another example could be 2, 6, 10, or another one could be 3, 9, 15, if they were all multiplied by 3, so on and so forth. So those are different examples of our step pattern. The vertical line going through the middle of a parabola is called our axis of symmetry. So that will always be given as x equals something, depending on where our axis of symmetry is. This will always pass through your vertex whenever we're dealing with parabolas. So now let's take a look at our first example here. We have identify the characteristics of a parabola from its graph. Use the graph to identify the key features of the parabola. In this question, I'm asking you, where's the vertex? Well, we see it's very clearly down here. What's the point, though? Well, the point is x value first, so -3, -4. That should be right there, -3, -4. Next question is our zeros. Remember, that's our x-intercepts, so don't forget x-intercepts is what our zeros are. So if I have an x-intercept here and one over here, well, it's just -5, -1. So that should be -5, -1. Axis of symmetry. Remember, that's a vertical line going through our vertex here. So it should be x equals our x value of our vertex. So it should be x equals -3, and there it is right there, x equals -3. Is it a maximum or a minimum? Well, looking at it, it opens up. That means it's a minimum. We have a minimum value. It doesn't pass that minimum value. What is the minimum value? Well, it's -4. Y equals -4 is our minimum value. Where's the y-intercept? So our x-intercept was along the x-axis. This means it's going to be along our y-axis, which is up here. It looks like it's 5. And it is 5. There we go. The direction, meaning the direction of opening, it's opening up because we see there's an opening up here. And our step pattern, to analyze that, you just take your vertex, go over 1. Does it go up 1 or 2? What goes up 1, over 1, up 3, over 1, up 5? There we go. very, very clear. Our step pattern is 1, 3, 5. Finding the vertex and step pattern from a table. Complete the table, circle the vertex, state the step pattern in the y-intercept. Luckily, the tables are completed in our example 1 here. So in our red table on the left, we're just going to look for our maximum or minimum value. It looks like we're starting at 9 and we're going down. That means that we do not have a maximum value. We definitely have a minimum value. And it looks like our minimum, our smallest number, our smallest y value is right there, -2, 0. So there's our vertex. Let's reveal that. And next is our step pattern. What's our step pattern? Well, we take a look at our first differences here. So 5 to 9 is 5, 3, 1. Look at that, 1, 3, 5. Step pattern's right there. If we go in the opposite or continue on, we'll see the step pattern repeat itself. So it's 1, 3, 5. And what's the y-intercept? Well, to find the y-intercept, it's actually pretty straightforward. You just find where x equals 0. In this case, our y-intercept is 4. So 4 should be our y-intercept. Perfect. Moving on to the next one. Let's find the vertex first. It looks like we're increasing from 0 to the -6, increasing there. And then we're decreasing. We're decreasing from 0 to the -6, decrease to from -6 to -8, and then we increase from -8 to -6. So right here's where it's turning around. That means that this is our vertex. So that means that 2, -8 is our vertex. Our step pattern, well, we went from 0 to -6, so we went down 6, down 2, up 2, up 6, up 10. Hey, 2, 6, 10. That's 1, 3, 5 just times 2. It's 2, 6, 10. Those are our step pattern there. Whenever I ask you for a step pattern, 3 terms is enough. I don't need all 4. 3 is plenty. What's our y-intercept? Well, like last time, I said find where x is equal to 0, and it'll give us our y-intercept. So in this case, it's just y is 0 for our y-intercept. For example 2, we have completing a table of values for a parabola. Start at the vertex and use the step pattern. So complete the parabolas with the vertex of 1, 2. In this case, I don't give you all of the information. I just give you the first step. In this case, we went from 2 to 3, so we went up 1. And if this is the vertex, that means, and it's increasing, that means we're going to increase when we go the opposite direction. So from 2 up 1, so up this way will be up 1. What's the next step after 1? Well, it's 1, 3, 5. So to go from 2 to the next step, we need to add 1, so we get 3. And then you add 3, so you should get 6, and then you add 5, you should get 11. And then it's reflected the opposite direction, so we add 1, then 3, then 5. So it should be the exact same numbers up here as it is down here. So 3, 6, 11, so this should be 3, 6, 11. It's just reflected across the vertex. In our next example, on the right here, we went from 2 to 4. That means we increased by 2. So instead of 1, 3, 5, we're going to increase by 2, 6, 10. And we just multiplied by 2 to get there. So notice that from our step pattern here, to get to our step pattern here, we just multiplied each term by 2. So instead of increasing by 3 for our next step, we'll increase by 6. And then to increase to our final step, we'll increase by 10. So 4 plus 6 should give us 10. And then 10 plus 10 should give us 20. Perfect. And now, because our y values are reflected across the vertex, should be the same numbers. However, I'm just going to write these out just to make sure that we have a little bit of a deeper understanding. So 2 plus 2 should give us 4. Just like it says up here, it was 4. And then increases again. We get 4 plus 6 gives us 10. And then 10 plus 10 should give us 20. And then we are good. So that should be everything for 1.20. You guys should be able to do the assignment now. If you have any questions, please post them on the forum so other students can see the questions and potentially answer them. If you find an answer that's similar to yours, please upvote it, and I'll check to make sure that you guys are going on the right path. If you solve something another way, please you can take a picture, post it. That it's always interesting to see how students do things a little bit differently. And all the best.